Hello, I am Kalyan. In this video, I will demonstrate the first of my two advanced MongoDB aggregation framework examples using the Pitch Development Project database. I will begin by briefly showing the structure of the collection, and then I will execute aggregation question 2 from the report in a stage-by-stage manner so that the impact of each aggregation stage can be clearly observed. Let's go to the question 2. So the question 2 asks us to analyze completed pitch development projects finished from the year 2020 onwards. For each surface type, MongoDB must calculate the average projected cost, average actual cost, and average cost variance. The pipeline must then generate a financial efficiency label indicating whether each surface type is generally over budget or within budget before sorting the results by average cost. So let me switch to the shell. Before constructing the aggregation pipeline, I will briefly show the nature of MongoDB collection. Each document represents a single pitch development project and contains top-level fields such as projected cost, actual cost, start year, end year, demand level, and usage ratings. The collection also includes embedded document structures such as contractor and supporting body, giving additional nested information within each record. I now begin the pipeline with the stage match. This stage filters the 1000 project records down to only those developments that have been completed and ended in or after the year 2020. Therefore, only recent completed projects are allowed to flow into the analytical stage that follow. I now add the second stage, which is the group stage. MongoDB now groups all the filtered projects according to the surface type field. Within each group category, 3 financial calculations are performed. First, the average projected cost is calculated. Second, the average actual cost is calculated. Third, MongoDB computes the average cost variance by subtracting projected cost from actual cost at document level and then averaging those differences across the group. At this point, the raw document list has been transformed into grouped financial summaries. Next, I now add the project stage. This stage reshapes the grouped output into a clearer finance report format. The internal MongoDB group ID is relabeled as surface type, while the previously calculated averages are retained. In addition, the project stage uses the conditional operator to generate a new budget status label. If the average actual cost average projected cost MongoDB if the sorry if the average actual cost exceeds the average projected cost, MongoDB writes over budget. Otherwise, it writes within budget. This demonstrates that the aggregation framework can generate intelligent descriptive classifications as well as numeric summaries. And finally, we can sort the groups. Rest. This stage arranges the three grouped surfaces category according to average cost variance in descending order so that the highest average overspend appears first in the final output. So to demonstrate the effect of altering an early stage in the pipeline, I will now tighten the year condition from 2020 to 2022. So let's run that as well. Because the match stage is now more restrictive, fewer completed projects are passed forward into the grouping stage. This causes the grouped averages, average cost variance, and final budget status values to change. This demonstrates clearly that small changes in an upstream change have a direct impact on the downstream analytical output. Yeah, this completes the first advanced aggregation framework demonstration. In this video, MongoDB has been used to combine filtering, grouping, mathematical cost variance calculations, conditional labeling, and final sorting with a single analytical pipeline. Thank you.